Welcome to the DIY Honda Garage channel. The diagnostic trouble codes, DTC, P0520-16 and P0522, are related to the engine oil pressure sensor circuit, specifically indicating low voltage scenarios. When the engine oil pressure sensor detects a voltage output that falls below an acceptable threshold, the powertrain control module, PCM, identifies this as an abnormality and assigns the corresponding DTC. This can affect the overall functionality of the vehicle, as the oil pressure is vital for engine lubrication and operation. The oil pressure sensor monitors the engine oil pressure to ensure that it is within proper range for optimal performance. The PCM utilizes this information to adjust the engine operation accordingly. Understanding the sensitivity of these codes is vital for promptly diagnosing and repairing engine issues, ensuring its reliability and efficiency. The Honda CR-V 2023 model is equipped with an engine oil pressure sensor that continuously monitors the oil pressure within the engine. This sensor is crucial for maintaining optimal engine operation by sending real-time data to the powertrain control module, or PCM. If the sensor detects an output voltage lower than the required value, it sends a signal to the PCM, which then logs the DTC P0520-16 or P0522. The PCM is located in the engine compartment and plays a critical role by overseeing various engine functions. It ensures components operate correctly, and any anomalies can lead to efficient vehicle performance. The oil pressure sensor itself is usually mounted near the engine oil filter, ensuring it has direct access to the oil flow for accurate readings. There are several potential causes for triggering DTC P0520-16 or P0522. A faulty engine oil pressure sensor is often the primary suspect, as its failure can lead to erroneous voltage readings. An open circuit within the wiring, either in the sensor circuit or connections, can disrupt communication between the sensor and the PCM, resulting in a low voltage signal. The PCM itself could also malfunction, producing incorrect signals and causing it to register these trouble codes. It is critical to explore these causes methodically, considering each component's role in the engine's lubrication management system and the obvious ramifications of low oil pressure detection. Drivers may notice several symptoms if their Honda CR-V is triggering DTC P0520-16 or P0522. One of the primary indicators is the illumination of the warning lights on the dashboard, specifically for the oil pressure. Additionally, decreased engine performance may occur due to improper lubrication as the oil pressure fluctuates unpredictably. Another concerning symptom might be unusual engine noise, particularly if the oil pressure is critically low and parts are not properly lubricated. It's vital to address these symptoms promptly to prevent further engine damage that could arise from insufficient oil pressure, affecting longevity and reliability. To troubleshoot the DTC codes P0520-16 or P0522, start by turning the vehicle to the on mode without starting the engine. At this point, the next key action is to access the Honda Diagnostic System, HDS, to check the rocker arm oil pressure, EOP, sensor voltage. If this voltage is recorded below 0.18 volts, this indicates that the failure can be duplicated, confirming an issue with the oil pressure sensor or related circuits. The HDS provides a user-friendly interface for monitoring sensor data, and understanding voltage thresholds is crucial in determining whether the oil pressure sensor is functioning as intended. This first step lays the groundwork for further diagnostics and component inspections. Next, disconnect the engine oil pressure sensor connector, typically a 3-pin connector. Once this connector is removed, Proceed to measure the sensor's output voltage while the vehicle is in the on position. A normal reading should register around 5.0 volts. If the voltage is as expected, the sensor itself is likely functioning appropriately, indicating that the issue lies in the surrounding circuit components. Conversely, an abnormal reading could signify a fault within the oil pressure sensor itself, necessitating replacement. It's essential to handle the wiring and connectors carefully to prevent damage during testing. In the third step of the troubleshooting process, the PCM connector B, comprising 101 pins, must be disconnected to inspect the VCC2 circuit integrity. The goal is to ensure that there are no open wires in the VCC2 line, which supplies necessary voltage to the engine oil pressure sensor. Using a multimeter, check the resistance across the circuit. A reading of less than 1 ohm indicates a healthy circuit. If resistance reads higher than 1 ohm, it indicates potential wiring faults that need to be addressed. It's of utmost importance to verify the circuit's continuity before pursuing further steps, as this could save considerable time and resources in the repair process. For the fourth step, you will conduct an inspection of the opsin circuit, ensuring that it has no shorts to ground. This can be quantitatively checked using a multimeter by measuring the resistance in the opsin line. Values should exceed 1 megaohm. If the resistance is lower than this threshold, it suggests that the circuit may have a ground short, impacting the signal returned to the PCM. Addressing such issues may involve replacing sections of the wiring that have become damaged or corroded over time. Properly diagnosing the opsin circuit behaviors contributes significantly to identifying if the oil pressure sensor operates within its intended parameters. In the final troubleshooting phase, if all preceding inspections indicate that the engine oil pressure sensor and wiring are functioning correctly, you will test the PCM itself. This involves thorough examination to check if the PCM is generating the expected outputs and can effectively receive signals from the oil pressure sensor. If the results from earlier steps are found to be normal, it is then systematic to conclude that the PCM is likely at fault and may need replacement. Diagnostic tests can be performed to confirm any deficiencies in the PCM functionality, ensuring that the repair process is efficient and targeted. Once repairs are complete, clearing the diagnostic trouble codes is the first step in final verification. This process ensures that any previously logged codes are reset, allowing only new data to be recorded. After clearing the codes, it's paramount to recheck the engine oil pressure to confirm all systems are functioning properly and that oil pressure falls within appropriate parameters. Subsequently, a test drive is essential. This provides the opportunity to monitor the vehicle's performance under real-world conditions. Make sure that the dashboard warning lights do not reactivate, which would indicate unresolved issues. A thorough check ensures the longevity and effective performance of the engine post-repair. To prevent encountering DTC P0520-16 or P0522, a robust preventive maintenance schedule should be implemented. Regular oil changes are crucial to ensure the engine receives adequate lubrication, which inherently reduces stress on the oil pressure sensor. Additionally, it is important to check for any leaks in the oil system, as low oil levels will negatively affect pressure readings. Regular inspection of wiring and connections, especially in high-stress areas, can prevent potential circuit failures. Performing these maintenance tasks regularly allows for early detection of problems, ensuring longevity and reliability within the engine's operation. In conclusion, dealing with DTC P0520-16 and P0522 highlights the critical nature of engine oil pressure and its regulation. These trouble codes serve as crucial indicators of potential issues within the engine's lubrication system. Prompt identification and resolution of these codes are essential for maintaining engine performance and health. Adhering to the outlined inspection and troubleshooting steps ensures a systematic approach toward resolving the issue effectively. Lastly, integrating preventive maintenance into vehicle care can significantly enhance engine lifespan, ensuring it operates well without the risk of triggering such DTCs in the future. Always prioritize proactive measures to safeguard your Honda CR-V's performance. Please like and subscribe to the channel. See you next time.